Hi, this is JD, and what we're going to be going over today is exponents and polynomials. Here's a preview of what we're going to cover. We're going to go over exponents, scientific notation. I'm going to introduce polynomials, maybe some evaluating, adding, subtracting. Then we're going to look at multiplying of polynomials, and then we're going to look at factoring and just the basic building block of factoring, which is finding the GCF. So here are the rules of exponents. So here are the rules. The first one here is the product rule, because you're multiplying. And when you multiply exponents, you add the powers together. Next is the quotient rule. Quotient because you're dividing. And when you divide them, and the base has to be the same, that's why these letters are the same, you subtract the powers. And wherever you start at, that's where you put your results. So if you start with the numerator, you would put it like this. You would put the result in the numerator. If you want to start with n, you can very well do that and then do n minus m, but that would be 1 over a raised to the n minus 1. Next is the power rule. So you have an exponent here, a raised to a certain power, and then that whole thing is raised to a certain power, n. And what you do with these is you would multiply them together. Next is the negative exponent rule. The negative exponent rule doesn't mean it's negative, it just makes it smaller. So a raised to negative m becomes 1 over a to the m. The one exponent rule, there's multiple exponent rules, but this is one of them, and it's the one exponent rule, which is uses the number 1. So anything raised to the first power gives you that anything, gives you that number. And then the zero exponent rule, anything raised to 0 power gives you 1. Now there's more rules, but we'll look over those in a moment. Here are some examples of the rules that we just went over. And here, typically they'll ask for you to simplify it, leave it as an exponential expression, which means that sometimes you just, if it's a base that's 5, like this x right here, that would be the base. If that's a 5, sometimes they might say to leave it. So that first one, x raised to the third times x raised to the fourth, would be x raised to the seventh. Because you're multiplying, you add the powers together. You don't have to memorize the names. It's more important that you know how to apply the rules. So here with letter B, y to the 10th over y to the 5th, it's a quotient, so you're going to be subtracting the powers. So it'd be 10 minus 5, which is 5. So you end up with y to the 5th. Letter C, x to the 5th, and that whole thing is raised to the 3rd power. Well, you're using the power rule there, and the power rule basically tells you to multiply these. So that'd be 5 times 3, which gives you 15. So that would be x raised to the 15th power. Letter D is using the negative exponent rule. The negative exponent rule flips it, makes it a reciprocal, or you could say just brings it over the bar. So you get 1 over x to the 4th. Letter E, which is 123,320 and 567 thousandths raised to 0 power. And remember, anything raised to 0 power is just 1. So the answer is 1. Here are the other rules. So product power rule. So when you have a product multiplying and it's raised to a certain power, it almost acts like the distributive property. And so you would raise each of those to that same power. Quotient's kind of similar. The quotient power rule is kind of similar. If you have a over b raised to the n, you would raise it each one of those. So that would be a raised to the n and b raised to the n. So let's kind of bring all of these rules together and using the product power rule as well. So, right, so we have something like this. Now to approach it, what I would do is I would simplify what's inside the parentheses first. You could very well raise everything to the third power, but you'll end up with very large numbers. So it's better to simplify first. So you'd simplify the number, simplify the a's, simplify the b's. So to simplify the numbers, you just simplify them. So negative 30 over 10 is negative 3. A to the 14th over a to the 8th. Well, using the quotient rule, so you would subtract the powers. 14 minus 8 is 6. Then b to the 9th over b to negative 2. This might be a little tricky here, but you're still subtracting. You're doing 9 minus negative 2, which gives you positive 11. Then what you would do next is, since this is simplified, you can't do anything with it anymore, you would raise each of these to the third power. So that would be negative 3 raised to the third power, which does give you negative 27. A to the 6 raised to the third power. Use the power rule. So that's 6 times 3, which is 18. And then here, 11 times 3, that gives you 33. And that would be your final answer. Now let's look at some scientific notation. And sign notation has exponents in it. Now a little tip. So what is scientific notation? Scientific notation is taking a number and putting it between 1 and 10. And it can be equal to 1, but not equal to 10. And it's 10, you would multiply it, so it's 10 raised to a certain power. And that power is an integer, which means that's either a positive or negative whole number. So here's a rough example of scientific notation. And I wouldn't memorize direction, because moving left, making it positive or making it negative, it switches when you're in between. So what I recommend is that you do it this way, and just remember this tip, that when it's a small number, that means this number right here is a decimal, then you're going to have a negative exponent. When it's a large number basically means anything larger than 1, then you're going to end up with a positive exponent. So small number as a decimal has a negative exponent in scientific notation, and a large number as a decimal in scientific notation has a positive exponent. By doing this little tip, that will direct you on how you convert it. So let me show you how to do that. Let's look at some examples. So that first one, those first two, it says write in decimal notation. So I have 3.2 times 10 to the third. 3 is positive, so that means I want to make it larger. So I'd move it 3 decimal places to the right. So it's 3,200. 10 raised to negative 5. Since that's a negative, it's going to be a smaller number, so I'm going to move it in the opposite direction. And when I say small, I mean it looks small. Both values are equal, so technically they're the same value. So a little tip works here as well. So we need to move the decimal place with this first one. So we're going to move it 1, 2, 3, 4, right? Because the number has to be between 1 and 10. So make it 5. Moved it 4 times. Since it's small, it's going to be a negative 4. So it'd be 4 times 10 raised to the negative 4th. Ignore the negative signs when you're transferring over in either process. So here I'm moving the decimal, so I move it twice between the 3 and the 1. And since it started off larger than 1, it's, again, ignore the sign. Since it's larger than 1, it's going to be a positive exponent, which means it's going to be a positive 2. So it'd be negative 3.17 times 10 raised to the second power. Now let's look at polynomials. And here, if the directions tell you to evaluate the polynomial when x equals negative 3, all you have to do is substitute. So I'm going to rewrite that. So letter A is 2x minus 7. Replace the x with negative 3. I'm using a parenthesis here. That's word of advice: if you're plugging things in and it's a negative, the best thing that you could do is use parentheses. Now the other thing is you want to make sure that you're consistent as well, and parentheses helps out with that. So then you just follow the order of operations. So you would multiply first 2 times negative 3, which is negative 6. Then you have negative 6 minus 7, which gives you negative 13. Letter B, we're going to plug in negative 3 again into x squared minus 5x plus 2 using a parenthesis. So exponents, I can also multiply this at the same time because they're kind of separate. So negative 3 squared is 9 because it's the whole thing that's being squared. This is like negative 5 minus or times negative 3, which is a positive 15. Since here this is a minus, that becomes a plus. And then you just add across, so 9 plus 15 is 24 plus 2, which gives you 26. When I tell you to evaluate, all you do is substitute and follow the order of operations. So here is a problem. The concentration C in parts per million of a certain antibiotic in the bloodstream after T hours is given by the polynomial equation. So it looks like it might spark up a little bit, but then go down. So it says, find the concentration after 3 hours. All you have to do in this problem is substitute T for 3. Replace T with 3. So that's what I did. And then just follow the order of operations. When you have something that has decimals in it, I would break out your calculator and start calculating it in the in-between steps. Some calculators you can just put this all at once. So again, the exponent and the multiplication here is separate, so I calculated them. Continue to simplify it. So I did negative 0.05 times 9. That gave me negative 0.45 plus 6 plus 2, and that gave me c equals 7 and 55 hundredths. So what that means is this. You're going to have 7 and 55 hundredths parts per million of the antibiotic in the bloodstream after 3 hours. And this is, it might not, this might not accurately represent what's happening in the bloodstream over the entire time span, but this is the model, or give you an estimate of what's in the bloodstream. All right, so parts of a polynomial. So let's look at standard form first. This polynomial is in standard form. It doesn't matter what kind of numbers are in front of the variables. What matters is that the exponents are positive, and they're positive whole numbers. There could be none, but notice that this is 1, 2, 3, and it's nice. There's no fractions with the exponents. They're not anything negative or anything like that. So this would be considered a polynomial in standard form. It's also in order. The degree of the polynomial, or degree of the terms, is the power of the variable. So degree of 9x cubed would be 3. 13x squared, or negative 13x squared, of that term, this degree would be 2, 1, and if it's just a number like this, the degree of that would be 0, because x is 0 is equal to 1. Now each of these would be considered terms, and include the sign as well. So this would be 9x cubed, negative 13x squared, 21x, and negative 7. Coefficient is the numbers in front of the variables. Variable would be x. Constant, going through these rather quickly, constant would be what doesn't have a variable. So here negative 7 would be the constant. Leading coefficient, you look at all these terms, the one with the highest degree is the one that's supposed to lead. So that would be the leading coefficient. Here would be 9. Again, coefficient is referring to the number in front of the variable. Degree of a polynomial, you look at all the degrees of each of the terms. The highest would be the degree of the polynomial. So here would be 3. Monomial, like a polynomial. Poly means many, like polymer, polytheistic, things like that. Poly means many. Mono, like monorail or monocle, means 1. So it's just one term. Here, this would be a polynomial because there's more than one term. Monomial just means that there's one term. There's also binomials. Bi means 2, like a bicycle. And trinomial, there's trinomials. Tri, like a triceratops, right? Triceratops has 3 horns. It's a dinosaur. So that means a trinomial would have 3 terms. I don't necessarily think that you see it in ALEKS, but you'll definitely see that those terms come up in college algebra. I guess I can use them here as well. All right, so let's look at operations of polynomials. So we're going to look at addition. Addition is basically just combining like terms. Subtraction Subtraction includes one extra step, so you distribute the negative and then combine like terms. You can subtract, and they might show you how to do that, but my recommendation is that you distribute that sign. If there's too many terms, sometimes you can get lost in all the terms if you're trying to do it all in your head. Really easy to mess up on the signs. So that's why I would recommend to distribute the negative first and then combine like terms. And then multiplication, when you multiply polynomials, you're just using the distributive property. And then GCF stands for greatest common factor. You might, it's also considered greatest common divisor, the largest number that you can divide those factors in by evenly. And it's the opposite of the distributive property. So you can work backwards using the distributive property to get what you started off with. And if distributing involves multiplication, then GCF involves working backwards, which would mean using division. You use division, but you don't necessarily see it. I'll tell you what I mean in a moment. So let's go over addition and subtraction first. So I'm going to rewrite that first one. Now I can just drop the parentheses when it's a plus sign. When it's a plus sign, I can just drop the parentheses. And then what I want to do is combine like terms. So I'm going to combine the x's. I'll use green for the x's, and for the constants I'll use red. So I'll make that another green, another red. And if I label them, and you can underline these, so underline them differently, like once, and then maybe this twice. Or you can rearrange it however you want to. So here, x squared just brings it down. Take the sign when you're combining like terms. And again, combining like terms, I think we went over that weeks ago. You add or subtract the coefficients together and you keep the term, here the variable part, the same. So, and take the sign. So that'd be negative 9x plus 2x, which gives you this negative 7x or minus 7x. And then 6 minus 5 gives you 1, and that would be a plus 1 since there's plus and minus signs in between these. And that's it, you're done. Now let's look at subtraction. You can tell a subtraction because there's a sign, the sign of the minus signs in between, where here it's a plus, the plus signs in between those. Distribute the negative sign first, and you're going to distribute it to the one on the right that comes after the minus sign. This changes the sign, so if it was positive, it becomes negative. If it was a plus, it becomes a minus. If this was a minus, it would then become a plus. So when you distribute the negative, it just changes the signs and then combine like terms. So 3x minus 5x gives you negative 2x. Negative 7 minus 7 gives you the negative 14. So you end up with negative 2x minus 14. Pretty straightforward with those. So now let's look at some multiplication. We're going to start off easy and then look at some harder examples. So here again, when you're multiplying polynomials, and this is multiplication because it's right next to it, you won't necessarily see the sign of the operator, the multiplication operator. So you won't see that, but since it's the 5x is right next to the square root, thinking of something else. When 5x is right next to the parenthesis, that indicates multiplication. it's the same for a square root. If you have a number right next to the square root, they're being multiplied, but that's for a different time. So take 5x and distribute it to both the 2x cubed and to the 3x. So write that out. So 5x goes to both of those, and then you would simplify both of those. You can multiply the numbers together, so that'd be 5 times 2, which is 10, and then x times x to the third, that would be x to the fourth, because you're adding the exponent, because you're multiplying, you add the powers together. So 1 plus 3, which gives you the 4. Here, you multiply the numbers, so it'd be 5 times 3, which is 15. X to the first times x to the first gives you x to the second. And these are unlike terms, so you can't do anything, so you would stop here. Let's look at another example. These are binomials, so this is a binomial times another binomial. 2 terms times 2 terms, which you think would give you 4 terms. And that's actually correct. So you can do that to check yourself when you're multiplying. So you would distribute, so you would take the 5x, distribute to the 2x and the minus 3, and then you take the 6 and distribute to the 2x and minus 3. So it looks something like this. And then you would distribute that again, right? So the 5x is going both to the 2x and a negative 3, and then 6 is going to each of those. And then you would simplify these. So that would be 10x squared minus 15x plus 12x minus 18. And before you simplify these, again, 2 terms times 2 terms will give you 4 terms before you combine like terms. So here you have to combine like terms. Negative 15x plus 12x gives you negative 3x. So you end up with the rest of those just come down. So that would be 10x squared minus 3x minus 18. And you're done. Here you have 3 terms times 2 terms. So what you would do here, 3 times 2, you would end up with 6 terms. Again, you distribute. So I can distribute in the opposite direction too, and that's what it looks like I did here. So I did x times x squared, x times 3x, x times 2, and then negative 5 times x squared, negative 5 times 3x, negative 5 times 2. And now I noticed that I didn't put the parentheses because you can just work that out and then simplify it. So then you simplify each of these. So you end up with x squared plus 3x squared. Again, remember these are raised to the first, so you're multiplying these and you'd add the powers, so that's why you end up with 2. X times 2, you can write that as x2, but it makes more sense to put the number first and then the variable, because you're going to combine like terms. So that would be 2x, negative 5x squared, minus 15x, minus 10. Then you would combine like terms. And notice what I did here, I did something different. I rearranged them. Again, we can double check ourselves. So it's 3 terms times 2 terms. So there should be 6 terms. Where I combine like terms, and there is. I rearranged them. So I put them in descending order. So you can either underline or you can put it in descending order. Sometimes it might ask you to do it when you're adding or subtracting, to do it vertically. You just need a way to organize yourself when you're combining like terms. So the squares combine and the x's combine. So the x cubed comes down. 3x squared minus 5x squared is a negative 2x squared. Again, it would be written as minus 2x squared. 2x minus 15x, that's negative 13x. Again, written as a minus 13x. And then minus 10. And that's it. Let's look at another example. And here we're going to factor. And when you factor, when you're doing GCF, I would focus on the numbers first and then the variables second. And actually the variables are going to be pretty easy to focus on. So what is meant by factoring or GCF? Well, you're looking at both these and you're basically looking at the factors and you're seeing what they have in common. And they have an 8 in common. By the way, that's the largest number that goes into both 16 and 24 evenly. So that would be 8 as the GCF. You can do a prime factorization as well. But if you know for sure what's the largest number that goes into both of those, you'll save some time by just seeing the number, the largest number that goes into both those. So then compare the exponent or the variable portion. And again, it's what they have in common. So I can write these out. X squared is the same as x times x. Y cubed is the same as y times y times y. Now you see what they have in common. So they have x's in common. And then they have y's in common. They have 2 x's in common, and then they have 3 y's in common. Notice that if I was to compare the variable portion with the exponents, it's the smaller one out of the 2. So this is x squared, and the smaller one out of these with the y's is 3. So the GCF is going to be 8x squared y cubed. Now you're pulling that out, so you're doing the opposite of the distributive property. So what times 8x squared y cubed gives you the 16x squared y cubed? That would be 2. 2 times this gives you that 16x squared y cubed. You can also divide. So 16x squared 16x squared y cubed divided by 8x squared y cubes. All those cancel. You're left with 16 over 8. That simplifies to just 2. So you can divide as well. What goes here is the what. So what times 8x squared y cubed gives you 24x cubed y to the 4th. It would be 3, right? 8 times 3 is the 24. And then you're missing 1x for this one, and you're missing 1y for that y to the 4th. So that's how you'd find the GCF. Practice a little bit. It's going to be helpful to do GCF factoring in this course because it gets a little harder in college algebra. So let's review. So I would try to learn this in this course. It's going to be very helpful for college algebra. All right, so let's review. We went over exponents. We went over the different exponent rules, and there was many of them. You don't have to memorize the name. The important thing is applying the rule. Then we looked at scientific notation. A little tip that I gave was if it's a small number, it's going to be a negative exponent. And if it's a large number, you're going to have a positive exponent in scientific notation. And that should tell you how to move that decimal. I introduced polynomials. Something that we saw before was to evaluate polynomials. We did that earlier, which is just substitution. We also looked at addition and subtraction. And with addition and subtraction of polynomials, it's kind of like before where you're just, when you're adding, you're combining like terms. And when you have a negative, you distribute the minus sign, and then you combine like terms. We looked at multiplication of polynomials, which uses the distributive property, sometimes once, sometimes twice. We also saw a little trick was that if I take the number of terms, you can also do that with that first example that we did. 1 times 2, that's going to give me 2 terms before I combine like terms. 2 terms times 2 terms is going to give me 4 terms before I simplify it. And then 3 times 2, 3 times 2 is 6, so that would give me 6 terms before I simplify it. It's just a way to check yourself. And then we looked at factoring and specifically looking for the GCF. And when you're looking for the GCF, focus on the numbers first, find the GCF of the numbers, and then find the GCF of the variable portion. And the variable portion is actually really easy. You just pick the smallest one. It's whatever they have in common. And that's it with polynomials. Thanks for watching this video. Please like, share, and subscribe. And if you have any questions, put them in the comments below. Thank you, and I hope you have a wonderful weekend. All right, bye.